Module 4, Lesson 1, Finding Probabilities Based on a Normal Distribution. Okay, this particular problem states the following. Suppose you have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. Okay, A says find the probability that a randomly selected adult has an IQ less than 115. Well, anytime you're dealing with normal distributions, the first thing you want to do if you're dealing with data is convert to z-scores. So you have a z-score formula. It's data point minus the mean over the standard deviation. Okay, so we're going to first do this, fill this in, and find out what our z-score is. Alright, my data point, at the point that I'm interested in, is 115. So I'm going to do 115. Okay, minus my mean, which is 100, divided by my standard deviation, which is 15. Alright, when I do this, remember the calculator steps for all of this stuff is on a separate Word document, so make sure you look at that about how to type all this stuff in. Okay, when I do this, I get a z-score of 1. Okay, that's the first thing you should always do when dealing with data. Convert to z-scores. Okay, once you do this, you have to look at the wording in the problem. Well, it states, find the probability that one selected adult has an IQ less than. That's extremely important. Okay, less than means you're going off to the left. When you're doing normal distributions, you're either going to use, we're going to use a large number. We're going to pick 1,000 or negative 1,000. So a very large number, a very small number. That way we'll be sure to get the entire curve. So if we're going greater than, you would always go to 1,000. If you're going less than, you're going to go to negative 1,000. So this is what I would type in my calculator. I'm going to do normal CDF. Now why is it CDF? Well, it's a cumulative distribution because we're doing anything less than 115. That's not just 115, it's a range of values. Then I'm going to start at negative 1,000, so now I'm going off to the left, and I'm going to end at my z-score of interest, which is 1. Now remember, when you type this in, you're going to go to second VARs, which is your distributions, and normal CDF is number 2, and then you just type in negative 1,000, comma 1. And as a decimal, you're going to get 0.8413. So it's about 84% that if you pick one person, that person's going to have an IQ less than 115. It's a pretty high percentage. Okay, well, let's do another one. What if we want greater than 131.5? All right, again, first thing you want to do is convert that 131.5 to a z-score. Now be careful when you type these in the calculator. If you're going to do this all at one time, make sure you put parentheses around this numerator or you're going to get the wrong answer. The z-score should usually be a number between negative 5 to positive 5, and that's really pushing it. Most of the time you're going to get one between negative 3 and positive 3. Okay, this gives me a z-score of 2.1. Okay, next thing I'm going to do, this time I'm going greater than. Okay, when I'm doing greater than, I'm still doing normal CDF. Okay, but this time I'm going to start at my z-score. And since I'm going greater than, I'm going off to the right, so I'm going to end at 1,000. And we just pick 1,000. It's just a large enough number to make sure we get the entire curve. You could probably use 100 and be just as accurate. Okay, for this I get 0.0179 if I'm going to use 3 significant digits. Notice it's much smaller, so the probability of getting someone with such a high IQ is very small. Actually, this is considered unusual because it's less than 0.05. Alright, and then the last question, so we did one less than, one greater than. What happens if we want to find out a value in between two numbers? Well, that's what we're going to look at next. Alright, what if I want to find, or if I select a person, and I want to find the probability or percentage between 110 and 120? Well, now we have 2 data points of interest. So the first thing we're going to do is convert both of these to z-scores. So remember, you have to have z-scores in order to do this. Now, of course, when you subtract this, you're going to get 10 out of 15. And, you need to make sure you reduce the fractions. You don't have to, but it's going to be better off if you do. This is 2/3, okay, which is point, if you're going to use decimals, I use at least 3 significant digits, so 0.667. Okay, when you do the other one, you get 20 over 15, which is actually 4/3. And as a decimal, you're going to get 1.333. And again, I would at least use 3 significant digits when you're doing these to make sure you're as accurate as you can be, since you are rounding. If you want to be extremely exact, then use the fraction. All right, then I'm going to do normal, CDF. Now, this time I'm not going off to one direction or the other. I want to know what is the percentage between these two numbers. So you're going to put your smallest one first, and then your larger one second. And this probability is 0.161, or about 16% of people. If I pick one person, I got about a 16% chance that I'm going to pick somebody with an IQ score, between 110 and 120. So this is how you do probabilities dealing with normal distributions.